Hi again everyone, Dr. Tom McNamara back for our course in college algebra. In this video we are going to look at the relationship between the exponential function and the log function. So after you are done with this, you should be able to simplify expressions that involve exponential and log functions. Okay, and some of these questions trip people up. So I would like to kind of review a simpler type of example. For example, I might throw this at a student. I might ask them to simplify this expression. Now, I've gotten tons of different answers to this when I ask students about it. One of them was, well, I can't do it because I don't know what the square root of 37 is. Fair enough. I really don't know what it is either. I know it's a little bit bigger than 6. And I definitely don't want you to take the square root of 37 on your calculator, get the decimal, and then square that. What I'm really looking for is, does the student understand that the process of taking a square root is the inverse of squaring? So if you take the square root of 37, you are getting a number such that when you square it, you get 37. And then you're squaring that number. So you are squaring a number such that when you square it, you get 37, so you get 37. Okay, the key idea is that the square root function and the squaring function undo each other, just like exponential and log functions undo each other. So let's look at a couple of quick examples here. Simplify each. Log base 6 of 6 to the 104. Okay? Now, think about what a log function tells you. A log tells you the power of the base that you need to use to hit this target. So for a quick review, log base 2 of 8 is 3 because if I take 2 to the third power, I get 8. So here's the target, here's what I want to use. What exponent do I need? So, like I said, don't get tripped up on a question like this. Your calculator probably can't even compute 6 to the 104. It'll give you something in scientific notation if it can. The whole point is you don't need to know what 6 to the 104 is. This is basically saying, what power do I need to put on 6 to get 6 to the 104? Easy. 104. That's the power you need on 6 to get that target. Something like this. 5, we're going to raise 5 to this power. Okay, 5 to the log base 5 of 7. Okay, so log base 5 of 7 is telling me a power. It's telling me the power that I should put on 5 to hit this target. What power do I need to use on 5 to get 7? I'm taking 5 to the power that I need to use on 5 to get 7. So I get 7. Okay, so the key idea is that log functions and exponential functions undo each other. So if you get a problem like this thrown at you, where you're like, I have no idea what 6 to the 104 power is, remember to kind of look at the whole thing. This isn't asking us to compute the decimal representation of 6 to the 104 power. It's testing whether we understand the inverse relationship of exponential functions and log functions. Similarly, down here, log base 5 of 7, I have no idea what that is. It's 1 point something or other. Okay? I know it's between 1 and 2, and that's all I know. But I know what this number does. Log base 5 of 7 is the power I need to put on 5 to get 7. And if I think about the problem that way, I can see, all right, I'm raising 5 to the power that I need to put on 5 to get 7, so I get 7. All right? So don't be tripped up by these kinds of problems. Okay? Think about the roles that log functions fulfill. And that's how you can reason these out really easily. As you can see, we didn't even need to use a calculator for these problems. Okay, so very easy problems.